So let's get started. Thanks very much for coming here tonight. Welcome to I think it's our fourth RubySig meeting. It's organized by SD Forum. SD Forum is a non-profit organization in Silicon Valley that organizes sessions organized by volunteers about software development. And so my name is Patrick Chanezon. I'm from Google, and with Greg Colodanato and Bosco So, who's not here today. Since a few months, we started organizing these RubySig meetings because there's a lot of interest in the Ruby language, and we wanted a place for Ruby enthusiasts to meet together and discuss about new ideas in this area. So this is our fourth meeting. Today we're kind of lucky. We have David Pollak, who's going to present domain-specific language, which is a very interesting topics. SD Forum has a few other meetings coming up, like one about the business of new media, October 25th. One about emerging technology showcases. It's about startups. So this one is November 30. You can check it out on their website, and they have a newsletter that you can take at the entrance as well. We hold these meetings every month, and this one was kind of announced at the last moment. We'll make sure that for next month we plan that a little bit in advance. Thanks very much for coming, and hey, David.
Thank you.
Show it to you.
Thanks for having me. I really appreciate it. I'm David Pollak, and thank all of you for cutting out time in your night and coming to listen to my chatter. I'm going to start off with a pop quiz. What's the most popular programming language in the world, bar none? Nope. 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 Excel. Excel is far and away the most popular programming language in the world. Millions and millions and millions of people know how to use it and use it effectively every day. It's a domain-specific language. It's a domain-specific language that one could argue launched our whole industry. Let me tell you a little bit about me. First of all, these are my kids, Daniel and Sophia. They're 2-year-old twins, and they're just a riot. My background, I'm a double major in psychology and economics. I'm a lawyer. And a lot of what I've done through my academic career is figured out how people make decisions, either as individuals or as groups. And as far as I can tell, a lot of it is implicitly based on how much things cost to do and what are the various different alternatives. And that actually is an important thread that runs through domain-specific languages and runs through why now in terms of domain-specific languages. More about me. I've been writing commercial software for 28 years. First piece of commercial software I ever wrote was a domain-specific language for the Federal Emergency Management Agency, back before they were a joke. Specifically, it was a language that ran on Apple IIs that allowed basically FEMA groups to build multimedia presentations to be automatically broadcast over TV stations in an emergency, basically emergency evacuation plans. And way back then, we were using $3,000 Apple II computers, and they were competing with $40,000 machines called Chirons, which were character generation and animation generation machines. It wasn't a lot. I mean, you really couldn't do a lot with 64K, but hey, it got the job done. In '92, I launched Mesa, which was the world's first real-time spreadsheet. And anybody here who used NextStep? Any NextStep users? All right. Anybody who uses OS 10, you can still download it and use it. In '97, I built the first web-based spreadsheet. Okay, it's the same DSL. 2001, I built 4 DSLs for web-based development. The grammar of the DSLs was, the syntax was based on XML, and the functionality, the domains were OR mapping, website navigation, multi-page input forms with validation, effectively wizards, and a collections to HTML table mapping program, which most of the people in this room go, well, that's pretty easy to do, to write a for loop and iterate over things. But if you're an HTML developer, it's hard. And when your domain is HTML, you want to be able to express things in a tag-based way and don't want to worry about classes and declarations and a whole bunch of other stuff.
Question.
Yes, sir.
What's a real-time spreadsheet?
Real-time spreadsheet is a spreadsheet that accepts data from external feeds and will recalculate as those feeds come in and display. There are lots, basically every spreadsheet these days does it. Back in '92, it was a big thing, especially for Wall Street traders, because they could tick data into the spreadsheet, have calculations that took place automatically, and trigger external events like trades. Yet more about me. By the way, please pepper me with questions, even tomatoes, whatever. I do strategy and technology consulting for both startups and public companies. I'm a hardcore coder. You just can't pull my fingers away from the keyboard. Although it's a lot tougher with kids now because I can't do those 18-hour stints of okay, I'm just going to write more code. My current focus is on customization of search and basically improving results from RSS feeds. So roadmap to the presentation. First of all, people complain that I don't put enough graphics in my presentation, so my daughter loves this picture. The presentation is going to come in 3 sections: philosophy, an example, and then a how to do it yourself. Yes, sir?
Do you have this presentation available online?
It will be available tomorrow at dppruby.com. By the way, it's been a just disaster of a day for me. I forgot my business cards. I spilled a hamburger all over my shirt just before I got here and had to stop at an Army-Navy store to buy this. And on top of it, I had one of those little remote control things for the Macintosh, left it in the car. Anyway. Technology should be driven by a balance of need and vision. And a lot of what drives, a lot of the big events in Silicon Valley, a lot of the big events that we're used to are the visionary events, the Macintosh, Netscape Navigator, things like that. But there's also a lot of need that drives us, and actually being here at Google, Google is an excellent example of not flashy. The technology may be visionary on the inside, but the interface to the user is so non-visionary, it is in a certain way visionary. You're smiling back there. But it was driven by the need for people to be able to organize vast amounts of information efficiently. Technology drives up the value of human time. You think back to Kernighan and Ritchie and Pike when they were developing Unix and when they were arguing that operating systems should be written in a high-level language rather than assembly language. Their argument basically boiled down to one day, not today, but one day, human time will be more valuable than computer cycles. That's true. I mean, you can buy a $300 PC at Fry's and, throw it away tomorrow. But a lot of consultants in Silicon Valley, an hour of their time is worth more than that PC that you can buy at Fry's and throw away or use for 5 years. Interchangeable machine parts led to the Industrial Revolution. And one of the things that is very interesting is how quickly hardware has evolved. Hardware has gone through Moore's Law. Every 18 months, there's a doubling in power. Software development hasn't gone through that cycle. In fact, the number of advances. I recently took a dive into Smalltalk. And this is a language that was fundamentally frozen back in 1980, 26 years ago. And there's so many ideas in Smalltalk that we're just getting around to today. Looking at the Smalltalk object hierarchy, it is gorgeous and beautiful and richer than any other object hierarchy I've seen. And it's a 26-year-old language. The software industry is not evolving and developing as quickly. And I will argue that One of the reasons for that is our propensity as developers to take the semantics of our business users, take the words that they use, take the actions that we are reducing down to code, and reduce them down into code that cannot then be restored back to the original semantics. So you lose the meaning. You lose the meaning just like making one-off revolvers. You know, Winchester made a fortune during the Civil War. How did Winchester make a fortune during the Civil War? By having guns that had replaceable parts. So you didn't have a unique gun for everybody. You had the same gun for everybody. And, you know, part of it broke, you could put a new one on. You could share bullets with other people. That was really valuable. We coders haven't figured that one out yet. And yeah, there are objects, but, you know, most object hierarchies are libraries that at a low level work, but once you get up in terms of the semantic meaning, in terms of the value, things get lost. And I mean, you look at the morass that is SAP. Every single SAP implementation is, you know, what, 250, 300 man years of work to re-implement the same accounting system. That indicates there's something wrong and broken. Sapir-Whorf, languages shape our thought patterns. I actually prefer Robert Pirsig's Zen in the Art of Motorcycle Maintenance, who made the same argument, but it looks a lot better when you say Sapir-Whorf. Lisp guys, Java guys, C guys, SQL guys, Smalltalk guys, all solve problems differently, all think about problems differently. And you know, I've been doing Java for 10 years. Before that, I did C++. Actually, recently did a C++ project and had to remember that I had to free memory. And it was just, it actually changed my thought patterns because I had to remember who owned the creation and the freeing of the objects. And that changed the flow of my program. Smalltalk is like phenomenally interesting because your editor gives you about 10 lines and you're kind of encouraged to make all of your methods fit into those 10 lines. And it changes things. Ruby, closures. I mean, yeah, you can do closures in Java or something obscenely, wrongly ugly that look like closures. But when you have closures, it actually changes, or at least for me, it changed the way that I code. And it changed the way that I approach problems. I'm sorry? I'm sorry. Complex business systems evolve based on the available technology. You have paper invoices, you have to have filing cabinets. You move to computers, you move to the fact that information can be shared across distance. It changes your business processes. Think about the idea of renting a car from a national or international car rental chain before networking, before credit cards. It's a fundamentally different process. There was a lot more risk to the rental car company. They dealt with that risk by charging you higher prices. There were a lot more restrictions on what you could do with the car. There were a lot more restrictions on who they would rent to. And also, the business processes drive technology. Relational databases are a very good example of something that has been driven repeatedly by business. And finally, I'll talk about the Macintosh curse. Files and folders. Who here used original Macintosh? You remember the Macintosh file system? Maybe you had a hard drive and every time you booted up, if you had more than 1,000 files in your hard drive, it would take like, 5 minutes for the Mac to figure out which files went in which folders. That's because the original Mac file system was tag-based. And it had to figure out what tags were associated with which files so it could present them to the user in terms of being a file in a folder. I think my Wi-Fi is going up and down. Sorry about that. And that was a carryover from the whole concept of Macintosh is a desktop and we will have computer equivalents of what are on our desk. Well, if you have a single piece of paper, it's difficult to put it in multiple files or put it in multiple places or tag it with multiple things so you can look at it different ways. But now, 22 years after Macintosh, people have discovered tagging. Anybody who's done any relational database stuff and tried to shovel the concept of a file folder and hierarchies into a relational database, it's a pain. Doing tags in a relational database is so much easier. On the other hand, it's also so much better for people, because people don't necessarily think in 10 levels of nesting of hierarchies. They think of, okay, this is a joke and it came from my wife, so I want to tag it with wife and joke. This is a joke and it came from a family member. I want to tag it with family and joke. So I can look at all my jokes, or I can look at all the things from my wife, and I don't have to worry about putting it in a folder or another folder. And if you think about the path that, the 22-year path that Macintosh led us down, and Windows, because it copied from Macintosh, and all of the thought patterns that have evolved from that, it's cursed us. And now, I mean, who are the guys who first started doing tagging hardcore? Was it Delicious? Google did it first, right? No. So the guys at Delicious said, oh, this is a lot easier. I'm just going to slap this with a bunch of tags, and I can tag one thing with multiple tags, and I can just look at my tags. Great. What a great idea, and it's changing the way that we're thinking. It's changing the way that people are organizing their information personally. And there are actually some enterprise products that were shown at demo a couple of weeks ago that use tagging at the enterprise level so that people can tag and share information. Social networking in the enterprise. More philosophy. By the way, if you guys are bored, just say shut up and get to the meat of the matter, Dave. No, okay. Why do computers exist? Tools for communication and persistence and retrieval of information. They're tools to make life easier and more fun, because a lot of us use computers to play games. For nerds like me, solving the problem is fun, but I'm a radical minority. And my guess is that most of the people in this room, there's a majority in this room that likes to solve problems. And the solution to the problem with the computer is the entertainment itself. And to a certain degree, that's a shame, because we let that run into, often, at least some developers let it run into the way that they think about solving problems for people who want the solution rather than wanting the tool, rather than having the joy of the tool itself. And I remember I got in an interesting discussion with an elderly relative of mine who said that she would never be able to use a computer. I said, do you use one every day? She's like, no, I don't. I said, and this was back in, I guess it was 95. And I said, you're currently using the most advanced computer and the most advanced network in the world. She's like, no, I'm not. I'm like, we're talking on the telephone. She's like, that's not a computer. I'm like, yes, it is. It's just the functionality of the computer and the power of the computer has been buried behind something that is so easy and something that is so intimate to just about everybody who has been born in the last 100 years. That we don't realize that it's a computer. And then these things called PCs popped up on our desk, and they were different than the computers that we were used to using. But the real cool computers are the ones in my microwave oven that figures out when the food is reheated. The real cool computer is the telephone that allows me to make a call or connect up to somebody. And with the SS7 database and roaming and cell phones, I'm not even calling a place. I can now actually almost call a person. I mean, just think about the coolness of and the power that those computing environments give to us. Business intent. I'm getting closer to DSLs, really. Business intent is critical to a domain-specific language. You have domain experts and you have the intent that they want to express. Business intent is an intended behavior of a system expressed by a business user. In other words, the person that wants the behavior to occur rather than some external third party like a developer or somebody else. Described using the semantics of the business user. Described in the words that the business user uses every day to describe the problem and the solution independent of the tool. And yeah, I mean, you got that feedback loop, so you'll talk about the invoice as if it's a piece of paper, and it's going to be another 20 or 30 years before invoices stop being like mentally a piece of paper for us. But the business intent is what the business user, what the guy who wants the thing built talks about, thinks about, and does. A domain-specific language is a collection of syntactic and semantic elements. I actually separate those two things out. It's an important separation. We'll get to it later when you're actually designing DSLs. The syntax of the DSL is separate from the semantics. A good example of this in computer programming languages. There is Java the language. There is Java bytecode, and there's actually a Princeton PhD paper that was done proving that there's a one-to-one mapping back and forth between the two. So even if you have bytecode, you can reconstruct the original Java program that the bytecode came from, and if you have a Java program, you can obviously compile it down into Java bytecode. So the two are syntactically different but semantically identical. And there's also an XML representation of Java, which is, once again, syntactically different than Java. You look, you do a grep or a diff, and yeah, they're wicked different, but they mean the same thing. Collection of semantic and syntactic elements that describe the business intent in a particular problem domain that can be unambiguously executed by the computer. And actually, one of the big things is whether it's unambiguous or not. One of the domain-specific languages that I'm going to refer to is SQL. Another one is HTML. And everybody in the room is going to go, those are so ambiguous. Oracle does SQL differently than Postgres, and you get different results. Okay, but they're substantially similar. I mean, yeah, HTML, you go to the W3C, and their reference description of HTML is different than Firefox. Well, the guys at Opera will claim that it's not different from Opera, but who knows? It's different from IE, but anyway. And that can be understood by a domain expert. So the domain expert can actually look at the syntax and the semantics of the domain-specific, of a program written in the domain-specific language or an expression, and they can understand what that means in their business domain. Questions? Those are my kids. Some DSLs. SQL. It's a domain-specific language for storage and retrieval of information. By the way, feel free to argue at this point. I actually did a dry run of the presentation earlier today with a couple of my nerd friends, and they said, SQL's not a language because it's not Turing complete. HTML, that's not a language at all. It's a bunch of tags. Feel free to jump in. Okay. Excel is definitely not Turing complete because if you don't fall back into VBA, there's no looping or branching. There's implicit looping and branching in Excel because you describe the results that you want to get, and you could actually put Excel into a loop mode where it will iterate until it gets close to no difference in the spreadsheet. PostScript is I think the only Turing complete language here. Ant might be Turing complete, I'm not sure. Ant, it's a nice way of describing a series of system build tasks. HTML, it is a domain-specific language for describing layout. Arguments? Pushback? Comments? Yes, sir? Oh, okay.
It seems to me that the narrower the domain, the less likely it's going to be Turing complete.
I don't know, because I would argue that you might have to have Turing completeness for describing some business problems. For example, repeating, let's say we had a domain-specific language for describing the process of collecting a bill. Collecting a bill that's been sent out, or that's a subset of a domain-specific language. You might have a repeat loop in there. I'm not sure. Let me.
I would argue SQL is a good example of something that is Turing complete because it's declarative, and that makes it very specific and useful, and not Turing complete.
Yeah. Why use domain-specific languages? The instructions to the computer more closely match the business intent. This is hyper important. I mean, it gets back to the, do we have interchangeable parts? Do we have semantics that the people who actually want the systems built can use? Or do you have the impedance mismatch and translation problem of writing a spec, which isn't actually, even if you write the words down in a spec, you're bound to miss stuff. The spec is then coded. And you have two problems with coding. One is the defects in your code. There are defects in every piece of code. It's the way of the world. And the second issue is you may have a misunderstanding, which is different than a coding defect. So you might have an off by one error or something in your code, which is a defect introduced by the programmer even though they understood the intent, and then there may be the programmer not understanding the intent or thinking they have a better way to do it or it's too hard to do, and you have all these problems. And the closer you can push the business intent to the actual business user, to the person that wants the system built, the better off you are. So if you have DSLs, you have faster coding and fewer defects because the stuff is closer to what the business user wanted. It's also, quite frankly, more agile because you can do iterations much more quickly. You don't have to go off for 6 months and do all of these things that build a complex system. You already have a lot of the underlying pieces because you've listened to your users and you've understood what their semantics are. And finally, you have more maintainable code. Yes, sir?
Just one comment. You had a slide earlier where you pointed out how the semantics kind of get lost. And I would just give an additional bullet point on that here.
Yes. And actually, that's why the code is less maintainable. And Perl is actually, I believe, at least in my experience, the least maintainable code that I've seen, because even simple meanings get lost very quickly in Perl. C++, simple meanings get lost pretty quickly. Java might be a little bit better. Ruby is good at maintaining meaning, but it only goes so far. And you basically lose the meaning in the pluses and in the, and even if you're a good coder and you comment your code and you have good variable names, you're still going to lose meaning. I will make another bold argument. Please disagree with me. DSLs actually have been the killer apps that have launched platforms. VisiCalc and 123 launched the Apple II and the PC. PageMaker, which is a graphical front end on top of PostScript, the PostScript DSL. And for those users of early versions of PostScript, it was a very, very thin layer on top of PostScript. Launched the Mac. Okay, I was fudging with Power Builder. I'm not sure if it's a DSL or not. And finally, Netscape Navigator. If you consider HTML to be a DSL, Netscape Navigator launched the internet as we know it. Yeah, I used FTP way back when. I knew a lot of people in college in the mid-'80s who used email and did that sort of thing, but it wasn't a household thing. It wasn't the most rapidly adopted technology on the planet. Netscape Navigator changed that. Okay, this is one of my big, the last thing is not a domain-specific language. It's syntactic sugar. And there's a difference. There are things that make it easier for developers to write code and make lines more readable. There are things that are syntactically more pleasing. I mean, I got to Ruby and I realized you don't have to put parens around everything. Boy, that makes code look great. You can have a question mark or an exclamation point in a method name. That's awesome. That's not a DSL. It's, by and large, the syntactic sugar is developer-focused rather than business user-focused. And my argument is that DSLs are focused towards the business users rather than towards the developers. Object-oriented, the failed meta DSL. Who here sat through IBM's endless presentations about how objects were going to like change the world? How many people had Fortune 500 clients that were going to fire all their developers and only hire object librarians? It was supposed to, OO was supposed to bring coding closer to business intent. And actually looking at Smalltalk and looking at the rigorous work that one has to do to write a good Smalltalk application, yes, but it requires a lot of work and a lot of refactoring and a lot of thought on the part of the developer. C++, forget it. Java, I think a lot of Java developers, it's easy to be sloppy in Java, and I think a lot of Java developers are. At least has been my experience. The business intent is lost in the sea of plus pluses and minus minuses, your point. Also with C++ and Java, there's so much time spent mapping in and out of things. I mean, I think 70 or 80% of the lines of code in the Java web apps that I've seen are getting stuff in and out of the database. Okay, that's being solved by Hibernate, but there's still that impedance mismatch. Getting stuff in and out of HTML, yeah, that stuff is starting to be solved. Rails is a good solution. Anybody here who's played with Seaside, it's a better solution for kind of having your program and having the HTML feel like they're similar. I looked at the specs for Rife the other day. Has anybody played with Rife at all? No. It's a Java object framework that has a bunch of stuff that Seaside has, and I don't know. But there's so much mapping that's going on that you lose a lot of the business intent. And finally, I'll get to a description of what the separation of concerns are, but the same guys who are writing the code, there's no way of saying there's a guy who's responsible for understanding what the library or the object hierarchy is supposed to be and the guy that's writing the code. Yeah, we have architects, but most architects that I've worked with are good coders. There's a lot less separation between the guys who are writing the code and the guys who are trying to figure out what the semantics of the business users are. Why now? Oh, that's my dog Archer. He's really cool. Yeah, I've got graphics. First of all, there are a lot of tools available for parsing stuff. Lex and Yak existed many, many moons ago, but they were really hard to use. There are a lot of tools that are getting easier for parsing XML, for generating overall parsers, and the performance associated with generating parsers is a lot less important than it was 10 years ago. I mean, when you had a 1 megahertz or 5 megahertz or 25 megahertz machine, if you had to spend 4 million machine instructions parsing your code before you could start executing it, that was a problem. When you've got machines that can execute 5 million lines of code or 5 million instructions out of cache in a millisecond, it changes things. Programmers can be less efficient and focus more on the high-level stuff. Kernighan, Ritchie, and Pike coming back. The Ruby syntax itself, and I'll actually get into the choice of syntax for domain-specific languages, but the Ruby syntax itself is very conducive to expressions that can be reparsed by humans and keep their original intent. Not having the parens, being able to have the nice automatic generation of hashes, and in Ruby 2, being able to have named parameters. Those sorts of things make it easier to write code that a human can reparse. The pain is very, very high. Once again, I'll go back to history. In the early 1920s, there was a study that AT&T did that estimated that, 70% of the unmarried women in the country would be telephone operators by 1950. That didn't happen. what AT&T did is they figured out how to use machines to do what people do. And I remember when I was a kid, I actually used to call the operator on a pretty regular basis to, like, you know, make a long distance call, do this, do that. I don't think I've talked to an operator, even a directory assistance operator these days, in years. I mean, directory assistance, I either go to Google and type in what I want, or I call something that winds up getting forwarded to one of these like automated things, and the automated things now have something on the order of a 90% success rate in understanding what I say and being able to look up what I say, which is pretty amazing. They still get away with charging $1.25 for it when it costs them 3 cents. Anyway, I'm sorry. So one of the pieces of pain that we're running into is a cross product of the maintainability pain and the fact that, yeah, during the dot-com era where people were paying, you know, flowing infinite amounts of money into hiring developers to, you know, build sites that would have movies delivered to your house by bicycle messenger in 15 minutes. Boy, do I miss Cosmo. And lots of people were being hired. And there was that same estimate. It was a very, very analogous estimate that, you know, there were going to be 8 million developers required across the world in the next 10 years. And then the bubble imploded, and, you know, those 8 million jobs aren't there. I mean, yeah, there are still high-tech jobs, but people are figuring out how to use computers to do what programmers used to do. So it's not stringing together the pluses and all of these simple instructions for moving bytes from point A to point B. They're stringing together higher level semantics. Also, I believe that the mindset is right. I'm not sure why, but I mean, just the fact that DSLs are something that people talk about, something that, you know, a room full of really smart guys are spending a couple hours of their time learning about. It's like you can kind of feel the tremors in the earth going, okay, DSLs, they really are important, and bosses will buy into them. You know, back in 2001 when we were doing DSLs, and I actually called them function-specific languages back then because there wasn't the term domain-specific language. I was like, okay, now there's this new language, click. Everybody's like, I don't want to learn a new language. Can you, like, just do this in Java for me? And it's like, no, it's like if you do it this way, it's going to be so much more productive. And, you know, we did a couple of case studies that said we were getting on the order of 10x productivity improvement between Java coders doing JSPs on Tomcat and the stuff that we were doing. And people were like, yeah, but I'm not going to, like, have my developers learn a new language. They just learn Java. I don't want to, like, people are willing to now say, okay, we can have domain experts, technology side and business side, we're willing to take the risk because the pain that we're facing in terms of maintainability and ability to generate code is so high. I have this long-term vision. Just before my kids were born, I spent a bunch of time in a hotel room in Boston writing code. It was like, okay, this is my last hurrah. I'm going to be able to, like, drink beer with my friends from Boston and write code for a week. Different people have different last hurrahs. I'm sorry, I'm a nerd. I believe that there will evolve domain-specific languages for different problem domains. You will have language architects that are a separate concern from the day-to-day developers that add secret sauce to dialects for their companies. And one of the things that I saw on Wall Street, a lot of Wall Street traders or a lot of Wall Street investment banks consider technology to be their business advantage. It's actually a company that was founded by the former CIO of Swiss Bank, that is putting together an open source stack of a lot of stuff that it takes to build a trading desk application, and just allowing the top 5% rather than the bottom 95% to be built as a secret sauce. So the secret sauce becomes the formulas that the quants put together rather than being able to deliver the whole system. I believe that that secret sauce, the efficiencies that UPS has developed over the past 100 years versus the efficiencies that FedEx has done over the last 25 years, those things will become the secret sauce on top of a domain-specific, on top of a generic domain-specific language about shipping and, you know, air travel and least cost routing and a whole bunch of other stuff. the developers will implement projects by gluing together the various different domain-specific languages for the different problem domains that are encountered by the business users themselves. So you have a shipping problem domain and a billing problem domain and a this problem domain and a that problem domain. The developers are the ones that are going to wire together, glue together the applications. And by the way, Ruby is one of the most excellent gluing languages around. It's my vision. I'm sticking with it. Let's review. Shared semantics makes systems more efficient. Computers are good tools. Describing solutions to the computers in the semantics of the business user is good. The tool and the mindset is right to create DSLs. Questions? Okay. One of the 4 DSLs that I did back in '91 was called sitemap. And it was a domain-specific language for describing website hierarchies, navigation hierarchies, and access control rules for each page. One of the problems that we ran into when we were developing websites was every time we would make a change to where an HTML or a JSP page was located in the directory hierarchy, we would have to go and recode 8 different pages that linked to that page. Every time we said, oh, a foo user rather than a bar user can actually access this page. You know, you don't have to be a super admin, you only have to be a normal admin to be able to change the state that a user is in. I don't know, something like that. You'd have to go through and change a lot of the different links in a lot of the different pages. And it became a very tiresome task. And it became one of the tasks that I'll call having to keep it in your head. So if you've got a site of a particular size, you've got one guy who can keep the site navigation in his head, knows all the pages that need to be changed if a particular thing happens, and will go through and change them. And if you're lucky, you've got refactoring tools that will grep through or do other stuff. We sat down and we said, okay, the HTML guy is just like driving us nuts because every time he changes something, we've got to have one of our developers, the guy with the stuff in his head, go through and find all the pages and make all the changes. Then we have to open a QA ticket, and we have to go through and QA it to make sure it's right, and it's just taking a lot of time. So why don't we write a system that describes page access rules, the text for links, and the hierarchy, the navigation hierarchy itself. So that, you know, if you're in the administrative section, you can, you know, change your username or change your password. And if you're in the, I'll get to the example that I actually used for this. I wrote a social networking site for my dog. I mean, you know, sometimes when I'm bored, I do stupid things. And so the social networking site allows my dog to have friends, my dog to write diary entries, the diary entries to be editable by the dog walker and by me and by my wife, but nobody else. The medical diary entries are only visible to me and my wife, not even the dog walker. So it's like, you know, you start looking at these complex rules, but I can also view the diary entries, a subset of the diary entries for other dogs. So it's like, okay, that's really complex. And being able to describe the complex rules in a simple document is a lot easier than having to code them in Java, either in access control files or in the JSP pages themselves or in tag libraries. So sitemap, website navigation hierarchy, page-by-page access control. When you want to display the navigation for a given page, only display the accessible links. Deal with changes in site layout in a single place. Think about, who here has done Rails work? Okay, so there's routes.rb, which basically describes if a request comes in for this URL, here's the controller, here's the method on the controller. By default, look up the name/name and you'll get to the right place. So this is Dogscape. It's your dog's life. And on top, I'm viewing the dog Dawson, who's a friend of mine's dog. And I can basically view Dawson's diary or view Dawson. But when I'm looking at Archer, I can view Archer, I can edit Archer, I can remove Archer, I can look at Archer's diary just like Dawson's diary, I can add a diary entry, which I can't do for Dawson, or I can add a dog. So basically, there are certain things that I am allowed to do to Archer that I'm not allowed to do to Dawson. And the page, the part of the page that displays the navigation itself doesn't know the rules. All it knows is it makes a single call and says, give me the available links. The user's on this page, it's this user, here are the parameters that were passed in as part of the HTTP request, give me the site navigation. There's a separate XML file. Well, actually, I'll get to the semantics that we use, then I'll get to the XML file. So the semantics were, we want to have a list of pages on the site with default links and access control rules. We want nested navigation hierarchy, and depending on where the user is in the navigation hierarchy, we might want to update the link text. We might want to alter the access control. There may be visibility to the link, which is different than access control. So you may have a link that isn't visible, but can still be linked, can still be clicked to. An invisible link in the navigation hierarchy may be something that's contained in the body of the page, but not necessarily in the nav bar itself. So an example of this is sign up with our service. You might want to have that on the home page if the user's not logged in. And finally, potentially optional parameters. So if I click on View Diary, there's an optional parameter for the dog that I'm currently viewing, having that dog's ID go in as part of the generated link. And finally, my Java-based calls, which is get navigation to valid links. Okay, I'm given a nested hierarchy of navigation. There's a separate call for get the link text and URL for a specific page if the specific page is available. So inside the body of a page, I might say, give me the link to the sign-in page, or I might say, is the sign-in page or the sign-up page visible? If it's visible, then give me the link to it. So the syntax that we chose, because we were boneheads, was XML, and I say that because we had this really great tool that was really powerful, and in addition to requiring that people learn a new language, even though it's a simple markup language, it also required that people edited stuff in a text editor rather than having a nice graphical front end. Big suggestion if you're going to implement a DSL, especially if you're going to choose XML as your syntax, put a polite front end on it. There are a lot of ways of building nice XML editors, graphical XML editors inside of Eclipse or your other favorite IDEs these days. Don't make the mistake that David made. It was a stupid mistake. Anyway, so we have a description of our pages. One of the pages is the URL is feedback. So the name of the page is feedback. The link text is feedback. The name is just uniquely identifies the page. So even if the URL changes, every place that refers to that page throughout the site doesn't have to change. And then the title. So when the page gets put up in your browser, the browser can get the title for the page. Okay, so this is just static. Everybody can go give feedback. The next one is administration. So the URL is administration/remove user. The name of the page is disable user. The link text is disable user. The title is disable user. Now we have a condition, which is a Boolean, which requires that the user who wants to access this page be a super user. The link will never be displayed to a user that's not a super user, and the page will not be accessible to anybody who's not a super user. So even if you know what the URL is, and even if you're logged in, if you go to that URL, you'll automatically be redirected to the home page. The super user little macro thing is actually defined in a separate part of the XML, separate part of the XML with what I'll call inversion of language, a Java snippet within the DSL that defines what a super user is. And it's effectively one call out to the domain object, which says user.is super user, and that's the call that determines super user. The last one is the item itself. So there's a series of nested items, which is your nav hierarchy. So page add diary entry refers to one of these pages. The condition is the user has to be logged in. They have to, there has to be a dog that they're currently looking at. And the current dog, can the user add entries, get the actor from the current page session? By the way, this is ugly, and the Ruby version of sitemap, much, much prettier. And then there's a parameter that we add to the URL that's generated, which is get the unique ID for the current dog. Questions? Tomatoes? So benefits of sitemap. First of all, the navigation just works, and you don't have all of your pages except one working the right way. They all work because they all refer to this master document that describes site navigation. It's wicked fast to do nav development and nav changes. I mean, once it actually took about 3 weeks to get the semantics right, but once we got the semantics right, our HTML guy became the owner of site navigation rather than the HTML guy and one of the Java guys and the QA person who had to go back and QA it. It was one person that owned it, and I think we actually used sitemap for our development and for various different projects in about 20 projects. Never had a problem with it. It always worked as advertised. The business guys understood access control. One of the projects that we used sitemap for was financial services project. Financial services guys were hyper concerned about security and access control, and we were actually able to go through with the business user, not with one of the tech people that was sent by the business user, but with the business user themselves to figure out what the rules were for the navigation to each page. Business users were actually able to understand the semantics, and once again, we never had a failure where the business user didn't get something that they were expecting to get. Code review and security reviews are like pie. I mean, they always worked quickly, and what we had to demonstrate early to the security auditors was that the implementation of the code matched the semantics of the domain-specific language. Once we proved that, the code reviews went really, really quickly because they believed that the underlying generated Java code was correct. It's basically saying this compiler will compile the C code as written into machine code that will execute as the C code, as you intend the C code to work. And yeah, there's always a bug in the compiler. Did anybody ever see that Dilbert comic strip where Dilbert's out on a date with this woman? And he goes, and then I realized it was a bug in the compiler itself. She pulls out Mesa, sprays it in his face, and he goes, what, did I go on for too long? Believe it or not, I'm married, but I still talk like that at home. Anyway, once we proved to the security guys, especially, that the code that was generated from the DSL was actually, it compiled down correctly, the code reviews went really, really quick, and they weren't crawling through the code, and they weren't worrying. What y'all came for? How to design a DSL. Why, what, who, the sausage factory part, and the time for you to be a hero. By the way, questions? Why? You got to identify the business need. Okay, I love coding for coding's sake, but it's not a good business case. Even though building DSLs is a lot easier than it was 10 years ago, it's still a substantial commitment on the part of a development team. You're basically going to be putting 2 or 3 developers aside for 2 or 3 months, at least. You're going to be sucking down immense amounts of time of the business users. There has to be a compelling business need for doing a DSL. There are a lot of compelling business needs, but you have to have one. It's not just like, ooh, I want to use this XML parser or this servlet engine because I want something new on my resume. It's a lot meatier than that. The 2 compelling needs, I mean, at the end of the day, there are only really 3 benefits to doing any kind of computer or any kind of product at all. It's going to make you more money. It's going to save you money from your current revenue stream, or it's going to make your customers happier. Same here. Your compelling need is you need much faster time to market with your existing code, or you need radically reduced maintenance costs. Basically, the cost of maintaining existing projects is so ghastly because the original business intent is lost that you really need to encapsulate the business intent in the program itself rather than having a human compiler compile the business intent down into executable Java code. Identify the constituents. Who currently defines and maintains the business process? And in a minute I'll get to thought leaders, but the person that defines and maintains the business process is almost always Thelma in accounting. It's not the high-level person. It's the person that has to do with the day-to-day nuts and bolts of the business. Those people are really the ones that define and maintain the business process. They don't necessarily define strategy, but they often define process. The business user who is currently caught in spec heck. You gave me the specifications, but they don't specify the whole problem. Go back. It's the guy who every time you generate specs, there's something wrong with them, and you never get past the spec process because the specs just never work right. That person is a key constituent for going and lobbying to do a DSL. And finally, the business user who's attending all the stand-ups and giving really excellent feedback. That person who cares enough about the business process itself that they're spending their time and their effort and giving you feedback if you're doing agile development on a day-to-day or 3-time-a-week basis. Those guys are important constituents, and you can often get them on board because you can show them how their lives are going to be easier with a little bit of upfront investment. Find the thought leader. That's the person that organizes the domain. It's Thelma in accounting. It's the person who maintains the file cabinet. It's the person that knows where everything is. It's the guy in the warehouse who has his system crawl inside their head. It's often a very difficult task because those people are sometimes crunchy. They're sometimes difficult to deal with. Spend time, spend effort, crawl inside their head. Listen to the words that they use. Spend a lot of time not talking about the tools that you have or how your tools and your ways are going to make things better for them. Understand what they say. Understand the words that they use. Understand why they made implementation choices. A lot of it is probably going to be anecdotal. Why do you do things this way? Well, back in '05, blah, 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 blah. But they're the ones that kind of have, over the course of their career, crafted processes. And yes, ultimately those processes will change through automation, but the processes exist the way they are now. And a good foundation for a domain-specific language is the existing processes and the existing words that are used to describe those processes. You need a big brain, huge ears, and a small ego. The last one I'm like a total failure on. And I was really lucky that doing spreadsheet development, I was dealing with Wall Street types who have egos even bigger than mine. So it's really easy to listen to them because if you didn't listen, they'd take the 2x4, and if that wasn't working, it was the aluminum bat, and if that wasn't working, it was the lead pipe. It's okay, I'll listen. For the web-based development languages, I had a co-author, a guy named Donnie Pletter, who is really good at listening and also really good at taking the 2x4 to the back of my head. And it worked out really well because one of the things that I learned from him was how to listen and how to understand the challenges and the solutions to the challenges that, in our case, the HTML guys were dealing with. But in a lot of other cases, it's other domains. So the first pass at the semantics. This is the hardest part. This is doing the outline for the book. This is getting those first words for the term paper out on a piece of paper. You describe a scenario using the thought leader's words. Focus a lot on the exceptions to the rules because coding to the way things usually work is a lot easier than understanding that most people's jobs are made up dealing with exceptions. So if you think about that from day one, rather than saying, oh yeah, my call to malloc will always succeed. Oh yeah, you know, file open, why should I check to see whether I get a -1 or not? It'll just work. Think about the exceptions that the domain, that the thought leaders are dealing with on a day-to-day basis, and keep those close to yourself when you're doing your scenarios. Do it on a whiteboard until you have unambiguous words that can be structured into pseudocode. The pseudocode that the domain expert can understand, and the pseudocode that you're pretty sure is unambiguous, so that you can then take and say, oh, that word means these 50 method calls and these 200 lines of code. This word means, and you can start mapping between the semantics that the business user is using and the code that you would normally write to express that sort of thing. Make sure that there is unambiguous mapping. Write up the scenario using your pseudocode. And then test drive. Sit down with the thought leader and 1 or 2 other people, describe the goals of the scenario, give them the piece of paper with the pseudocode on it, and see if they get it. See if they understand the words that you've written down in their English, in their language, that you know how to translate into a computer program, to see whether that language actually describes the problem domain. Okay, so we have pages, and the pages, going back to the sitemap example, we have a page of HTML. Okay, that's one distinct element. So what are some of the attributes of the page? Well, there's this, there's that, there's a title, there's a link text. Sometimes it'll be programmatic, sometimes it won't. There are conditions, there's permissions as to whether the page is visible or not. So that's like how some of those semantics started evolving. We just sat down and hashed it out. And let me tell you, there were 30 iterations of sitemap before we got it, so that it didn't change for a very long time. But the HTML guy was able to look at the code and say, okay, I get it.